Welcome to this explainer. Okay, today we're diving into a massive, frankly fundamental shift that's happening right now across modern factory floors. Look, if you're working in industrial automation, you already know the landscape is changing and it's changing fast. The days of just, cycling outputs based on limit switches, those are pretty much behind us. We've officially entered a whole new era of complex data handling. Okay, let's dive into this. Why exactly are modern controls engineers leaving ladder logic behind? Ladder logic has been the undeniable staple of industrial automation for decades, right? It's comfortable, it's highly visual, and yeah, it gets the job done for simple logic. But, and this is a big but, the sheer complexity we're dealing with today is quite literally forcing a major change in how we program. The problems we're tackling now, they require tools built for heavy data, not just simple relays. So here's our roadmap for today. First, we'll look at the automation paradigm shift. Then we'll pinpoint exactly where ladder logic struggles, followed by why structured text, or ST, is winning out. After that, we're going to look at some real-world proof with a pump control example. And finally, we'll wrap up by talking about the next generation of engineers. We're covering both the high-level philosophy and the practical under-the-hood proof, so stick with me. All right, let's kick things off with Section 1, the automation paradigm shift. And this brilliantly illustrates what's going on. Today's PLCs do way more than just cycle outputs. They are highly connected data hubs, right? They're talking to cloud databases, they're integrating with robotic systems. Now, to be fair, ladder logic still has its place. It remains excellent for discrete logic, and for an electrician on the floor doing visual troubleshooting, it's great. But structured text, it is the clear winner for modern demands. When you're dealing with complex math, intricate state machines, and heavy data handling, ST gives you clean, Git-friendly version control and beautiful single-line equations. It honestly leaves those cluttered ladder blocks entirely in the dust. Moving on to Section 2, where ladder logic struggles, or forcing complexity. We really have to empathize with the modern controls engineer here. Trying to force modern math into traditional visual rungs is, well, it's painful. It requires these cascading function blocks that just completely clutter up your screen, and worse, they obscure your actual intent. But then you look at structured text, and it handles all this with incredibly clean single-line equations. It tackles multi-step math, string manipulation, and nested logic exactly like high-level languages. Think Pascal, C, or Python. If you need to iterate through arrays or recipes, a simple for or while loop in ST totally replaces what would otherwise be a massive cascading nightmare in ladder. So let's shift gears to the solutions. Section 3, why structured text wins and how it's becoming the industry standard. First up, and this is absolutely crucial, version control and DevOps workflows. Seriously, this is a real game changer. Instead of fighting with those proprietary binary graphical files that just completely break standard merge tools, and come on, we've all been there, right? Structured text programs are stored as standard text files. That means you get fully compatible Git-friendly workflows with clean line-by-line code diffs. The absolute relief of being able to manage branches, track your code history, and resolve merge conflicts easily and reliably, it's huge. Now, this standard text format also perfectly enables modular and object-oriented programming. Thanks to modern IEC 61313 standards, ST lets you use classes, interfaces, and inheritance to build truly reusable libraries. Think about scaling up. Instead of going through the error-prone, hair-pulling process of copy-pasting hundreds of graphical ladder rungs just to set up 50 identical motors, ST lets you cleanly instantiate them as objects in seconds. It's incredibly efficient. So the crucial point is how all of this ultimately bridges the gap between IT and OT, the whole Industry 4.0 shift. Today's PLCs literally have to talk to cloud databases. They handle MQTT messaging, they interact with complex vision systems. Just imagine for a second trying to parse a JSON payload file or manage a string buffer in ladder logic. It's incredibly painful. Honestly, it's nearly impossible to write legibly. But in structured text, managing these modern network communication protocols feels completely natural. All right, let's get into the practical stuff. Section 4, real-world proof with pump control. Let's look at a concrete, undeniable proof of concept using a classic crossover scenario, lead lag pump rotation with auto skip. Basically, this is a system where multiple pumps alternate every cycle. If a pump goes out of service for a fault or maintenance, the system automatically skips it and grabs the next available pump. To build this in ladder logic, you're forced to manage array index pointers, check status bits, handle variable length loops. It requires multiple rungs packed with cascading counters, comparison blocks, and shift registers. It gets messy fast. But watch how structured text handles this. It does it beautifully in just a few highly readable lines. Step 1, you initialize a dynamic loop. Step 2, you run an immediate conditional check for a healthy pump. And then step 3, this is the big aha moment. You trigger an instant loop termination using an exit statement, the absolute moment a healthy pump is found. See, ladder logic forces you to sequentially evaluate every single rung on each scan, which means you have to create complex interlocking just to prevent false triggers. Finally, step 4 uses simple modulo-style array wrapping for seamless wraparound logic. You completely ditch those clunky math overflow registers. Now, what's really interesting here is the massive difference in effort required to scale a project. Think about what happens when your facility expands from, say, a 4-pump system to a 12-pump system. Ladder logic demands that you manually add 8 entirely new sets of rungs, wire up all the new comparison blocks, and completely rewrite your bit shifting and counter sequences. It is a massive headache. But with structured text, you literally just update your integer variable for the number of pumps. That's the whole shebang. Literally, you just change the variable to 12. That's it. That single integer change, along with tweaking your array size, handles the massive scale up. The loop dynamically adjusts to the new number automatically. To put that into perspective, the reduction in engineering hours and the massive drop in potential bugs is just staggering. And that brings us to our final section, Section 5, the next generation. We have to look at how this next generation of engineers is tackling complex sequencing and batch processing. Sequences like fill, mix, heat, and discharge. Ladder relies on these messy sequencer output blocks, those SQO instructions, or cascading latch and unlatch bits. And let's be real, those are a total nightmare to debug when step conditions start jumping around. But ST uses case statements. These act as highly readable state machines that make modern batch processing completely intuitive. And this demographic shift in the workforce is powerful. Take this quote. Learning ST feels intuitive to a new generation of engineers, whereas visual ladder rungs often feel archaic and restrictive for software design. It hits the nail on the head. Engineers graduating today are heavily trained in text-based programming languages, Python, C++, Java. When they look at ST, they see a familiar, powerful software design environment. But when they look at ladder, they see a restrictive interface originally designed to replace physical relays. For them, it feels like a massive step backward. So what does this all mean? The industry's shift towards structured text is accelerating dramatically. From complex data handling and Git-friendly version control to OOP standards and IT integration, the benefits are absolutely undeniable. So I'll leave you with this. Look at the sheer complexity of your current factory floor. Are you going to keep forcing modern data through legacy rungs, or are you ready to migrate your legacy systems to the future of automation? Thank you so much for joining me for this explainer, and I'll catch you on the next one.